Welcome back to the Winisd tutorial video set. This is episode number 3, and I'm going to get a little bit further into the graphs of Winisd. The previous video, we went and described a little bit of the transfer function magnitude graph, which is, in my opinion, probably the most important graph. Alright, so we will be speaking about the transfer function magnitude graph. We had spoken about the transfer function magnitude graph. We're going to speak a little bit more about the rest of the graphs involved with Winisd. So without further ado, we're going to open up Winisd. I am going to maximize this. Open up my previous project that you guys had seen on the last video, the DD715 box. And here is that function magnitude graph again that we were looking at before. So amongst the function or the transfer function magnitude graph, there are several other graphs that I myself look at, but there's plenty others that I don't know. Again, I'm not a professional with this program. I did not design this program, and I am still learning with this program, so bear with me if I give incorrect information. I do apologize for that. I will try my best to make sure I edit into previous videos to make sure that I'm giving you guys the most accurate information about this program. So, but for now, just take my word for it. I'm giving you as much as I can, and I'm going to try to remain to the accurate information that I have retained from Winisd here. So we are going to go ahead and go up here at this transfer function magnitude. If you click on this, it's actually going to display the rest of the graphs that you can go ahead and pick up on here. So one of the other graphs that I actually like to work with is actually the cone excursion. Cone excursion is actually going to show you how far your cone is going to move throughout the multiple different frequencies here. So the cool part about it is it's actually really accurate. With the box that I have currently, I have been kind of watching the cone. Now, I don't know exactly how much it moves, but I can guesstimate, and it's really accurate. As long as you give it the correct information, it works very well here. So one of the first things you're going to notice is you're probably going to ask what it is this red line is right here. That red line actually represents the xmax value that you had given Winisd when you had either entered the information for your driver that may not have been specified, or even just selected one. So again, like this red line, it doesn't mean you're going to do any damage beyond it, but it does mean that you will lose efficiency and you will lose control of the subwoofer at that point. So again, it's not a damaging point. It's a point at which you'll start to lose your efficiency of the subwoofer. So ideally, keeping your curve underneath the red line would probably be the best bet. I'm still playing around to really figure out how to bring it below this line in terms of the box itself. I do know that you can bring it below that line just by changing your wattage input. So right now this is at 1200 watts. I'm actually going to go ahead and put a different value into here to kind of give you guys an example here. So if we brought this system down to 800 watts, you're going to notice that that line remains underneath the xmax here. So if you really think about it, it would make sense. Okay, if you put 1 watt of power to the subwoofer, it's not going to move. Okay. And because of that, you're going to notice that line is almost flat all the way across the bottom of the graph because the subwoofer is not moving. You're not giving it power. So as you start to increase your power, there's 10 watts. Here's 100 watts. Here's 1,000 watts. Okay? So, like I said, obviously by changing your input wattage to the subwoofer, you're going to change the xmax here. So but what I do use this graph for is just to make sure that I'm staying well within a very safe limit of the subwoofer's capabilities. With that being said, I'm not really looking too hard at the xmax value. I'm actually looking at the xlim value, which is the value at which the subwoofer reaches its mechanical limits. For my DD715, that mechanical limit was 80 millimeters. And this graph doesn't even graph up to 80 millimeters, and you can see that my peak, even at a frequency so low that my box won't even register it, I peak out at 28 millimeters. So even if I'm trying to burp 16 hertz, which I'll never try to do in this box because this box it's not gonna work at 16 hertz. You know, if we go back to our function magnitude here, look at this, negative 10 decibels. You know, so I'm not even close to my F1, where the F1 displays, you know, your first frequency that actually starts to register. So again, 16 hertz, I'm not going to be playing anything near that. So I'm actually going to be keeping my my use around 19 to probably 19 to 30 hertz or so. And as you can see, you know, I'm well within a very, very good range of movement for the subwoofer, even at go back to my 1200 watts here. Oh, not 120,000, or sorry, 10,000. But yeah, 1200 watts right here. You know, this is what I'm looking at. So I'm still maintaining really good control, especially inside of the tuning frequency of the box. I think I'm going to go ahead and make a video later on about tuning frequencies of the box and really what it does to the subwoofer and why it works the way it does. Because you're going to notice a lot of really low points in these graphs when it comes to your tuning frequency. And there's a reason behind it. There's a science behind it. So just stay tuned for a video on explaining tuning frequencies of boxes and stuff. So. But like I said, that's about what you're looking at for cone excursion. Again, it's just it's the actual linear motion of the subwoofer, measured in millimeters. So your y-axis is going to display millimeters, and then again your x-axis is going to display your frequency range measured in hertz. So by clicking and holding and moving your mouse pointer, you're actually going to sweep the graph. You can also click on specific points in the graph. You don't have to click on the line. You can click anywhere you want. It's just going to move that x-axis to the location of your mouse, and then your y-axis will line up with wherever the line intersects. So that is cone excursion explained for you guys. Let's just check up on time here. Okay, so we got a little bit of time left. Let me see if there's another one we can go through that's going to be a little bit less time. SPL should be a pretty quick one here. So the SPL graph is literally what it says it is. It is a theoretic SPL output of your sound system at a certain frequency. So again, your wattage that you input in signal source will directly affect this graph here. And another thing that's going to affect this graph is your tuning frequency. If we take a close look here real quick, remember, tuning frequency right now of the box is 21 hertz. That's down here. Now if we go back to signal, 1200 watts, our peak here is 21 hertz at 118 decibels. Now this is a theoretic number, okay? This is not guaranteed you're going to hit 118 decibels. But one thing I do want to do real quick again is, as I spoke with you guys before, I plan on making a 45 hertz port as well. Now watch what this decibel rating will do. Boom, that sharp peak again. At 47 hertz, I have a theoretic output of 129 decibels. Again, it looks very similar to your transfer function, right? And your transfer function says at 47 hertz, you're going to have the highest gain, okay, at 12.3 decibels of gain. All right, now if we go back to your SPL, check this out, 47 hertz. All right, noticing a trend here with that correlation between transfer function and SPL. So again, like I said, SPL is literally what it is. It's your sound pressure level, SPL, output, the theoretical output, okay? I have yet to actually run any of my systems on a bench to really find out what I'm getting for SPL value, but we're going to go ahead and cut this video off here at this. So that was just a quick explanation of SPL and cone excursion, and we'll catch you guys on the next video.